Example 9. A normal distribution has mean mu and variance, known variance sigma. Wow, this is difficult. You know why it's difficult? Because all unknown, all symbol. This is a known sigma, unknown mean. Then they give you n. Sample mean x bar. Wow, no number. Never mind. The null hypothesis is being tested. This one mu equals to k. Correct? This one they tell you, ma. And find the, in terms of x bar, mu's n in sets of values for which this is rejected in favor of this. So therefore we write this. Just copy and paste. It's very easy. Correct? Null hypothesis, two-tailed test. Don't know what to do for hypotesting question, just follow the steps. Step 1, step 2, step 3, level of significance. Step 4, when H naught is true. When H naught is true, then wait. Then what? Do we do Z test or T test? Thank you. Z test or T test? Z test or T test? Z, because it is a known population variance. It's a known population variance. Alright, it's a known population variance. So we do a Z test. Oh, sorry. We are. But then how do you write the test statistic? Can write, right? Actually, Z equal to x bar minus k over sigma over root n. All are unknowns, correct? K is copied from there, sigma is from the question, n of course. Can? Then you say, how to compute? I don't know how to compute. This one printed for you, right? Okay, good. Let's digest this diagram, Ken. Let's digest this diagram. The question says that the H naught is rejected. In order for it to be rejected, that means your value lies in the rejection region. So first, can I say that this is our first step? I need to find the rejection region. This is the first step. This is the first thing to do. How do we calculate the rejection region? We use the level of significance. Correct? We use and the level of significance is given as 4%. If the level of significance is 4%, then this must be 0.02, this one must be 0.02. How do we calculate this value? We will look here. How do we calculate this value? We inverse norm 0.02, 0.1 because it's a standard normal. Correct? Z standard normal. So you want to find lower bound area 0.02, you inverse norm 0.02, mean 0, standard deviation 1, you get that. Okay? How do you get 2.05? Actually, by symmetry, you just take the positive number. Don't even need to repeat this guy. But you want to check, you can check. So clearly, we can find the rejection region like that. Okay? Actually, that's all we need. Correct? That's all we need. We need to determine, now we say that, okay? Now we say that the Z value must be smaller or equals to negative 2.0537, or the Z value must be greater or equals to 2.0537. In order to fall in the rejection region, my standardized Z value must fall in the rejection region. This one. Question? All okay? How do you find the standardized Z value. You find it from your X bar, the sample mean. Correct? That's why I emphasize you must write your test statistic here. The big Z random variable is the big X bar random variable standardized. So a standardized Z value is gotten from the small X bar. Correct? So this must be small X bar minus K over sigma over root n must be smaller equals to negative 2.0537, or X bar minus K over sigma over root n must be greater or equals to 2.0537. Now remember what we want? We want the set of values K can take. Set of values of K in terms of what? In terms of X bar, sigma, and n. So actually all you need from this point onwards is to make K the subject. I don't think I need to say more. Okay, just make the K the subject. Got time enough? Let me see. Okay, better put dot dot dot. Okay? What you will end up with is the set of values like that. Okay, just make K the subject. I don't think it's very difficult. Yeah? Wait, why is it not in 3SF? I have no idea. Okay, wait. Edit this a little bit. Nicer. 3SF lah, hor. No need so many. Can? All you need is to make K the subject. Example 10. In a rice packing factory, machines are known to deliver into each sack an amount that is normally distributed with mean 25, standard deviation 1.95. During routine check, you have n equals to 50 now. You want to check whether it's in excess of 25. Using a 5% level of significance test, find the set of values for the sample mean. So now you know, now it's interesting that the sample mean is unknown. This little x bar, unknown. There's no way of using GC actually. Okay, there's really no way of using GC. Cannot use GC. Let's do part 1 first. Never mind, don't know how to, cannot use GC, we do the same thing. Step 1, define. Step 2, now hypothesis mu must be equal to 25.0. Now, you want to check whether the, this is interesting. You want to check whether the machine is delivering an amount in excess of 25. Correct? Yes, in excess of 25. So therefore, the alternative hypothesis should be mu greater than 25. I know some of us may be a little bit confused when you look at the question here. You say, I want to lead to a conclusion that the machine has not over-delivered. I think it all makes sense. Why? If you reject H0, if you reject H0, what are you saying? You are saying that mu is significantly larger than 25. Correct? So that means the machine has over-delivered. Correct? So if you do not reject H0, you are saying that the machine has not over-delivered. Correct? There's a double negative here. Okay? There's a double negative. So Because whenever we do hypothesis testing, we always, if we reject H naught, then we say that there's significant evidence that the mean is very far away from your assumed mean. Then there's significant evidence that we reject H naught and so on. This is more or less true. Correct? Yeah. So therefore, when you read the question, it's like that. Therefore, it's set up in H1 like that. So never mind, we do all these level of significance stated, test statistic written, Z test. Why Z test? Why Z test? Because n is large, sigma square known. Right? Sigma square known. Is sigma square known? Yes, sigma square is known. Alright? We continue. Now we cannot continue actually, cannot continue by GC. Because if you bring up your GC, you say, how do we do? Say, I want to do T test, right? Whatever lah, Z test, right? Sorry. Then what do you enter? There's this column, X bar. I cannot fill in, unknown. Stop. So don't think that actually hypotesting is that easy. Just use GC. But you really have to understand. At this point, you got stuck. Cannot use GC. So what do? We go back to our bell curve. Go back to our bell curve and we check that we can calculate the rejection region. Correct? Given the level of significance of 5%, it's actually similar to the previous example. You are given 5%, you are doing a one-tail test, you are clearly able to do inverse norm to find this rejection region. Correct? Given this 5%, you know how to find this rejection region. So, maybe I write down just in case some of us are not sure, or you can go back and revise. This is inverse norm 0.9501. Correct? Then you get this value. Now, to conclude that the machine has not over-delivered, your standardized value of X bar must lie here, not in the rejection region. Because if it lies in the rejection region, you would say that mu is larger than 25. Therefore, you would have said the machine has over-delivered. Am I speaking too fast? Okay, okay. One more time, okay? Slowly, One more time. The X bar must lie here. Because you would want to conclude that the machine has not over-delivered. Because if the X bar were to lie here, you would say that the machine has over-delivered. The mean is significantly larger than 25. So therefore, to conclude that the machine has not over-delivered, you therefore say that H naught is not rejected at a 5% level of significance. Alright? So which means the standardized value of X bar must lie here. Must lie here. Must lie outside of the rejection region. Lie outside of the rejection region means the Z must be less than 1.6449. That means Z must lie outside of the rejection region. That means Z must lie outside rejection region. Correct? So to lie outside rejection region, make X bar the subject, then you can arrange your values. Okay? You may notice that I added here. Even though answer is like that, I added a lower bound of 0, and it's just common sense, right? Yes? That X bar is the mean mass, so therefore it must be positive. Part 2. Wow, really the timing is perfect. 3 more minutes. I can finish exactly. No need to start linear regression. State with the reason whether central limit theorem has been used. Use or not use? Talk to your friend next to you. Use or not use? Yes? Good? Consensus? Don't need to tell you answer, okay? You all go and figure out. Yeah, actually, quite stupid, right, me? Actually, I give you answer here. It's just that I cover this one. It's not used, because it's already given that the amount, that means X already follow a normal distribution. You don't need to use central limit theorem. Correct? X already follow a normal distribution in the question, therefore it has not been used. Last part. The examiner's favorite part is to blend this together with stat 6. Correct? Using the set of values for the mean in one, find the probability of not rejecting the null hypothesis when in fact the machine is delivering a mean amount of 26.4. Wow. What? Yeah. What? What are they talking about? Shh. One thing at a time. 2 more minutes, huh? If I were you, I will break the question up. I will highlight this bit. When in fact the mean is delivering, the machine, the machine is delivering a mean amount of 26.4. That means that this is the population mean. Yay! Then we know mu, right? Mu is now a constant, is a known number, right? Yeah. And do we know population standard deviation? We also know, because population standard deviation is 1.95. That means, therefore, we say that X follow a normal distribution. I write here, but I think it's in the question. Or rather, it's in printed for you. They're actually very good. That means this is true. Then after that, we go back to what they want to ask us to find. Then find the probability of not rejecting the null hypothesis. Wait. You think. What do they want? Not rejecting the null hypothesis. Not rejecting the null hypothesis. Very confusing. See, in part 1, can you have attention, please? I know, 10:15, but I really need to tell you this. Look, what we said was this. Can you have attention? In X bar, the small X bar, the sample mean, thank you. In X bar, you got lie between 0 and 25.5. You would not have rejected the null hypothesis. Correct? You would not have rejected the null hypothesis. So actually, what do they want? They want you to find the probability of X bar lying between 0 and 25.5. They actually want to find probability X bar between this and 25.5. Correct? Want to find this. Given what? Given this. Correct? Because if X bar lie between 0 and 25.5, you would have not rejected H naught. Correct? Done. The rest, you can just not the end of my lecture, still got one more chapter, okay? That's why I told you, if you don't like my face, then too bad, okay? Quite a long series of lecture by me. Thank you. Thursday we'll start new chapter.